Hello, my name is Mark and today I present you our article A New Approach to Clustering Districts and Connections Between Them based on Cellular operator data. Let's begin. According to a report by the agency Via Social, the world's population is more than 7.8 billion people. More than half of this population lives in cities. One of the concepts to improve the quality of life in the city is the smart city concept. The concept is to manage the city's resources and infrastructure based on information technologies and Internet of Things technologies. One of the data sources for building a smart city can be the aggregated data of cellular operators. During its operations, each cell phone exchanges signal strength and delay information as shown in the figure on the bottom of the slide, with several base stations. Technologies are available to locate devices based on such base station data. Due to the development of algorithms for processing such data, the data presented on this slide are currently available for Moscow and the region. Our works aim to propose new formal ways of describing areas and connections between them based on such data, as well as to carry out clustering of areas and relationships in the resulting feature spaces. The task of describing areas has been relevant for a long time. Previously, to solve it, data from census and social surveys were used. The data was expensive to obtain and quickly became outdated. There are new methods based on the analysis of satellite imagery or electricity consumption. They use machine learning tools. The data of cellular operators are more accurate since mobile phones are personal. They are almost always near a person. In large cities, there is more than one SIM card per person. We propose two feature spaces for describing areas. The first feature space is two-dimensional. The first feature of this space is the average number of people in the area during working hours, from 10 to 18 hours. The second one is the average number of people at night, from 23 hours to 7 hours. Min-max normalization is used to eliminate the influence of the size of the regions. Formulas for calculating these features are presented on the left side of the slide. In the second feature space, features are built based on the analysis of the traffic flow in the morning rush hour. The first feature is the average rate of commuting people. The second one is the average rate of people who leave the area during the morning rush hour using the metro. Formulas for calculating features are presented on the right side of the slide. For clustering of connections between districts, we propose two-dimensional feature spaces. The first feature is the total volume of movements between districts. The second one is the volume of movements to work. Formulas for calculating these features are presented on the left side of the slide. We choose such a combination of features because the districts to which residents travel not only to work are attractive in the social sense. They can contain shopping centers, sports grounds, parks, as all such areas may contain summer cottages. We also build clustering separately for the total volume of movements and the volume of movements using the metro. For clustering into dimensional spaces, we use Kamin's method. Dendrograms are built in one-dimensional spaces based on hierarchical agglomerative clustering. Let's consider results of our computational experiments. Based on the data of cellular operators, it is presented on the top of the slide for Moscow at left and for Moscow and region at right. 5 clusters are identified. For choosing a number of clusters, we use select coefficients analysis, and select coefficients plot are presented in the bottom left figure. 5 clusters identified. It includes a cluster of working districts marked as 1 on the slide, and representatives of this cluster are Arbat and Tverskoy district. A cluster of residential districts, it is here, it is third cluster. It includes Yuzhnaya Butovo, Marinette zone, it is marked as 3. And pre-intermediate clusters, it is fourth cluster. It is more working than residential. 0 cluster, that's more residential than working, and the second cluster, it is equal cluster. In the second feature space, describing the districts, a blue cluster with a higher metro use was highlighted. It includes Kuzminka and Izmailovo. Cluster with low rates of commuters but average metro usage, it is C-wave cluster, is highlighted too. A purple cluster is a cluster of approximately the same metro utilization but with a higher rate of people commuting to work. We can see 2 problem clusters, green cluster with low metro percent and yellow cluster with low values of 2 features. It is Vnukovo, Kapotnya and Molzhaninovsky hoods with low transport accessibility. We build dendrograms of Dolgoprudny's connections with our territorial units. On this dendrogram, the total traffic flow, we can see cluster containing Khimki. It is here. Residents of Dolgoprudny work there, have summer cottages, and also go there to the shopping center. In addition, the territorial units are neighboring. In the diagram of connections using the metro, working areas such as Tverskoy and Arbat are distinguished. Tverskoy is separated in cluster itself. Note that despite their remoteness, there are also districts in which stations of a green line of the metro are located. For example, Zamoskvorechye, which is here. One of the reasons is the presence of a bus that circulates from Dolgoprudny to the Hovrina station of this metro line. In the last clustering, the settlement of Khimki, green cluster, Fedoskinskaya, Mytishya and northern districts of Moscow, are yellow cluster, are distinguished. In these areas there are objects of interest of Dolgoprudny residents, such as shopping centers, transport stops. Note that Dolgoprudny is the closest point with urban infrastructure for the Fedoskinskaya settlement. The rest of the districts are distinguished mainly by the share of commuting. We can see it here. It is the largest in the purple cluster. It is contained inside districts as Arbat and Tverskoy. Thank you for your attention. You can ask me questions. Be healthy. Goodbye.